Every single year, our planet Earth makes this incredible journey of nearly 600 million miles around the sun. And we all have this picture in our heads, right? A perfect circle. But it's not. Our path is actually a little bit oval-shaped or eccentric. Now, for centuries, we've had one explanation for why. But today, we're diving into a pretty radical new one that suggests we might be missing a huge piece of the puzzle, a fundamental force of the universe we haven't accounted for.
So that's the big question. Why the wobble? Why isn't our orbit a perfect circle? Like I said, the standard answer has been around forever. But according to the research we're looking at today, a paper by Mathis, that standard answer, well, it just might not hold up.
So here's the debate in a nutshell. The standard theory says our orbit gets warped because of the gravitational pull from other planets. Simple enough. But the author we're looking at argues that we're only seeing half the picture. He says we're completely missing a cosmic push, an external force that mainstream physics just doesn't recognize.
Okay, so let's quickly unpack that conventional view. It basically says that as Earth is cruising around the sun, it's constantly getting these little gravitational nudges and tugs from all the other planets, especially the big guy, Jupiter, and our close neighbor, Venus. The idea is that all these tiny, relentless pulls are what stretch our orbit out of that perfect circle shape into a slight ellipse. But here's where the author says the math starts to get fuzzy. He actually calculated the maximum possible gravitational pull from these other planets, and what he found was that their combined force is still 16,000 times weaker than the sun's grip on us. His argument is pretty straightforward. A force that tiny could never, ever cause the kind of orbital wobble we can actually measure.
And yeah, he doesn't pull any punches about it. He calls the math in the standard model magic, saying it's basically fudge to make the numbers work. He's arguing that the gravitational forces are just way too small to be the real cause, so something else has to be going on.
Which, of course, brings us to the million-dollar question. If we throw out the textbook explanation, what on earth could possibly be making our orbit eccentric? And this is where the author introduces his own pretty mind-bending theory. His answer is something he calls the charge field. Now, to get this, you have to forget about gravity being just a pull. Instead, imagine that all of space is filled with a constant, universal wind of photons. It's not pulling things together, it's a pushing force, like a steady current flowing through the entire cosmos, exerting pressure on everything.
So where is this push that's affecting Earth coming from? Well, according to this theory, it's the combined photon wind blowing from the four gas giants in the outer solar system: Jupiter, Saturn, Uranus, and Neptune. They're the ones creating this external pressure on us.
Okay, so an external push from the outer planets. It's a cool idea, but how does that actually connect to the specific, measurable shape of Earth's orbit? Where's the evidence?
And this is where the theory gets really elegant. The author claims that this one single external push is responsible for two things that seem totally unrelated: the tilt of Earth's axis, the reason we have seasons, and the elliptical shape of our orbit. One single cause, two big effects.
And here's the key. He's not just guessing. In a previous paper, the author had already done the math, calculating the effect of this charge field from the outer planets as the cause for Earth's axial tilt. So in his view, he's already solved one half of the puzzle.
That calculation gave him this number, 0.374. Now, this number represents the calculated strength of that push from the outer planets compared to the sun's pull on us. And according to the author, this value perfectly explains why our planet is tilted on its axis. So just think of it as a measurement of that constant external force. And right here, this is the light bulb moment. The author claims that if the constant force causes the planet's tilt, then the variation in that force has to be what causes the orbit's eccentricity. It makes sense, right? The outer planets are always moving, so that external push isn't perfectly steady. It fluctuates, and that fluctuation is what he says stretches our orbit into that oval shape. And you won't believe how simple the math is that he uses to connect them. He starts with his number for the tilt, 0.374. Then, he needs a way to represent the variation of that force. So for that, he uses the average distance of the outer planets, which is about 23 astronomical units. He divides the constant force by its variation, and he gets 0.0163. And here it is. This is the payoff. His calculated value is 0.0163. The actual, known, measured eccentricity of Earth's orbit? It's 0.0167. I mean, that is an incredibly close match. For the author, this isn't some wild coincidence. It's proof that one simple mechanism is behind both the tilt and the shape of our orbit. So, what this all suggests is a whole new way of thinking about orbital mechanics. The standard model of an ellipse needs two focus points inside the orbit to work. But this new model suggests an orbit is actually shaped by one internal focus, that's the sun, and a variable push from the outside.
The author points out that this idea even has its own geometric shape, called a Cassini oval. Now, you don't have to be a math whiz to get this. A standard ellipse is defined by 2 points inside it, but a Cassini oval can be defined by 1 point inside and 1 point outside. It's a completely different geometry that he claims is the perfect model for an orbit being shaped by the sun's pull from within and an external push from without.
Which really just leaves us with one final fascinating question to chew on. What does it mean when a simple, almost back-of-the-napkin calculation seems to explain a cosmic mystery better than a complex model we've used for centuries? Is it just a lucky guess, or could it be a sign that we need to rethink the very forces that shape our universe? Thanks so much for joining me.